friends, students, welcome back. So today, again, from the same series, that is Wearable series projects, we are discussing one more project, that is Smart Wearable Clock project with some enhanced features. This is also in MicroPython. That means the codes are in MicroPython. All right. So with enhanced feature, what do you mean by enhanced feature? That is step counting battery voltage display. As you can see on the screen in the photograph, the battery voltage is displayed and the step count will also be displayed along with the time. So what are the components we have used? Again, the same RP20400 board. That is the smallest board available with for RP2040. That is the microcontroller number. OLED display we have used SSD 1306, which is available in the market and cheaper in price also. So this is a project. Please remember, it's not a color display, but even then you can buy a color display of different size, square, round and all, because in the clocks we have square as well as round shape also. So again, the lithium polymer battery has been used, so rechargeable batteries there. You can see on the corner. If you have used here a vibration sensor for step counts, you have used a vibration sensor. Any of the sensor you can use it, of course. 100K resistor, 2 resistor we have used it. How the connection I will just explain you. 100K 2 resistor, that is for voltage divider circuit, breadboard, jumper wires and few of the components, that is battery holders, resistor and all. This thing we have already used it. The wiring diagram, as you can see here, very simple. That is LCD connection to connection. One is connected to SDA. The LCD SDA is connected to pin number 0. That is GPI 0. LCD connection SCL is connected to GPI 1. And the sensor connection, that is sensor output, is connected to GPI 4. There is one more connection, that is for your voltage divider. It is connected to GPIO 26. How the resistors are connected, you can see in the figure here. One is connected, one end is connected to the positive supply, another is connected to ground, and output is connected from exactly the center point, the center connection of the two resistors, that is R1 and R2, which are of 100K each. So that will be working as our voltage divider. If needed, you can use 10 kilo ohm pull down resistor for the sensor if needed. That is sensor, or you are using two switches for controlling or adjusting the time and minutes, right? One is for plus and one is for minus. That also we have used it here. So you can use a 10 kilo ohm resistor, that is pull down resistor, to ground. That is, it is connected to ground, 10 kilo ohms. Okay. So enhanced feature, what are the enhanced feature? Button based time adjustment. That is, you can adjust the time with the help of button. Please remember, here we have not used the external battery. That means we are avoiding one more sensor here. Okay, right. Then second is battery voltage is displayed. What is the percentage or what is the condition of the battery? What in the voltage formation, it will be shown on this. Step counts are also using vibration sensor. Simple codes in MicroPython. I have given the codes over here. So the connection wise, OLED connection and button connection, then you have ADC connection. ADC is nothing but analog device control, that is pin number 26, what we have connected, that is nothing but voltage divider. So it is a basically GPI 26 is a ADC point, right? And vibration sensor is connected to pin number 4. Rest you can just check it out. Some calculations have been done for clock as well as for the minutes and time and other things. So this is in MicroPython. You can directly copy the code and put it in your Python ID, MicroPython ID. Okay, so simple project. Now let's go to the lab and check out the thing, students. So we are in our lab. So I'm just showing you the practical of this clock. So I will just explain you what is there in this. So as you can see here, the smallest board, that is your Raspberry Pi Pico 0, display 0.96 inches, 2 switches, and 2 resistor or voltage divider. This is my sensor. You can use any sensor, but here I have used a tilt sensor. Okay? So I'll show you. Like you can see here, in now right steps are 07. It is showing 07. Okay. Now it has stopped 09. Okay. The battery voltage is 3.1. Why? Because I have given connection. Pin number 26 is connected to plus and minus of the battery. Okay. Right. So these 4 connections is given from 3.3 volts SCL SDA, as I have already shown you in the PPT or PDF. So I have given supply right now from the computer. It's running with the help of a computer. Okay, there's 2 buttons are for changing the time if you want to adjust the time. Okay, I'm not using any external battery or any other this thing for changing the timing or maintaining the timing. This is a simple project for variable. Okay, so usually in a smart clock, you have 2-3 things extra apart from your time. Okay, so that's what I'm showing you. One is steps and one is battery voltage. These are the 2 new things what you have. Okay, please remember. So I'm just changing the step. You can see the steps are changed. That means whenever there is a movement of your body or your hand, our watches have, the smart watches have a sensor inside which will change the steps, or which will rather starts the step. Okay, and battery voltage, whatever the battery is there, so it will keep on telling you what is the percentage of battery, whether you need charging or not. So this is a simple project what I have made it and just wanted to show it to you. Very simple project. The beginners, the students who are going for project, science fair, school students, very simple to make and very easy. It is based on MicroPython. Please remember, okay? It is based on MicroPython. Codes in Thorny ID. The codes are in MicroPython. Very simple codes. It is just Python codes only. So there are 2 files, that is SSD 1306, that is your display, and there is a clock py. So what I suggest is clock py, you just change it to main py. Suppose I'm selecting this, and what I will do is I will go to the file and I will just go and say save as. Okay, save as. Where to save it? I will just try to save it in the Raspberry Pi Pico. All the files you should save it in Raspberry Pi Pico. Select this. Okay, then select main py. Main py. Okay, so I have selected main py. Why? Because main, if you select main py, then only it will be stored. Okay, it will be stored. Otherwise, if you any other this thing py this thing, if you give it compulsory, again you have to reopen the program and you have to load it again. So I'm saving it main py. All right. So he said main py is there, but we can change. I said yes. Okay. So it is saved with the name main py. Okay. So I will just load this program. You can see here. Now the program has started over here. You can see the program has already started over here. All right. So this is the way 2 files, SSD 1306, that is about the display, and you have main py. These 2 files should be there, both of them in MicroPython.